Welcome everyone. In this video we're going to go over a question from 13.4 that has shown up on a previous exam. Here we are back in fall 2015 and we're going over question number 3. So find the velocity and the position functions of a particle that satisfies the following conditions. So it looks like we're given information about acceleration. We know that the initial velocity is j plus 2k, and we know that the initial position is I plus 4k. And again, our goal is to find velocity and position. Okay, so to do this, I need to remember that when I integrate acceleration, I'll get velocity. So I'm going to go ahead and integrate acceleration. So integrate, and let's see, I have cosine of ti plus 6tj plus 4e to the 2tk. And so when I integrate that with respect to t, right, remember I integrate component by component. So I'm going to have the integral of cosine is sine. The integral of 6t is going to be 3t squared, and that's in my j component. And finally, the integral of 4e to the 2t, well, this one, technically there's a chain rule, right, because there's this 2t, aka this is technically a u substitution. But if you do a little guess and check, I hope that we can get 2e to the 2t, right? Double check. If you take the derivative of this, you should get back to where we started. And that's, of course, in our k component. Now, again, the big thing whenever you integrate a vector, you get a constant vector of integration, right? So this is going to have maybe a c1i plus a c2j plus a c3k. So something like this. Okay, and those c1, c2, c3 are going to be found out based on this information here, right? When you plug in 0, you should get out j plus 2k. So if I plug in 0, well, let's see what happens here. If I plug in 0, first of all, again, I want to get out. Let me go ahead. I'm going to write 0i plus 1j plus 2k. Just to be very explicit here. So 0i plus 1j plus 2k. So I'm going to go ahead and plug in 0 for t. So I'm going to have here 0i plus 0j plus, okay, when I plug in 0 here, e to the 0 is 1, so this is going to be 2k. Plus another c1i's, c2j's, and c3k's. Okay, so the question is, right, here are all my I stuff. 0i's and c1i's. When I add those together, I have to get 0i. So what should c1 be equal to? Well, I hope that you get out 0, right? So this should be 0i. Okay, how about all of my j stuff? We have 0j plus c2j should equal 1j. So what should c2 equal? Well, hopefully 1, right? 0 plus 1 equals 1. And then finally, how about my k stuff? So I have 2k's plus a c3k, and that should be equal to 2k's. So let's see, I already have 2 of them, so it looks like I want 0 more. So I'm going to choose 0 for c3. Alright, so that's saying that my constant vector should be 0, 1, 0. If I was to go ahead and put this all together, I would have that my velocity, and let's go ahead and maybe just write it over here, that my velocity would be, and I'm going to group all the stuff with i's, so this would be sine of t plus 0 i's. All the stuff with j's, so in this case, let's see, I have 3t squared plus 1, and this is all the stuff that's next to j. Right, so again, here's the 3t squared, right, and then I added 1, right, that was my constant of integration here, and the j component was 1. And then finally, for the k's, it looks like I have 2e to the 2t, and let's see, plus 0 k's. So something like this. And if you want to, if you're worried about not being able to see that these are vectors, the I, j, and k vectors, we can go ahead and put the little arrows over them to really say, these are my vectors. All right. If you thought that was fun, right, we need to do it again in order to get position. All right, so let's play the exact same game one more time, and that's going to give us r of t, the position vector. So I'm going to integrate velocity to get position. So when I integrate sine, let me go ahead and maybe write over here, r of t. When I integrate sine, I'm going to get negative cosine of t, and that's going to be in my I component. When I integrate 3t squared plus 1, that's going to give me t cubed plus t. That's in my j component. And when I integrate 2e to the 2t, that's just going to give me e to the 2t in my k component. All right, and again, whenever you integrate, you get a constant of integration. So again, this is going to be, maybe instead of C1, C2, C3, just to show that these things don't have to be the same, I'm going to use D1, D2, and D3. Otherwise, you can get confused. If you use C1, C2, and C3 again, well, up here you said C1 was 0. And C2 was 1, and C3 is 0, right? Those don't have to be the same. So I'm going to use different notation here. That's why I use the D's. All right, and when we plug in 0, we should get out, let's see, 1i, 0j, and 4k. So 1i, 0j, and 4k. Let's go ahead and see what happens. So if I plug in 0 everywhere I see a t, looks like I'm going to have negative 1i here. Let's see, I'm going to have 0j, and then I'm going to have 1k. Okay, plus d1i's, d2j's, d3k's. Okay, so let's go ahead and again we're going to put together maybe all of our i's. So I have negative 1i plus d1i should be 1. So what plus negative 1 equals 1? Well, I hope that's 2. Next up, if I group together all my j's, so 0j plus d2j should equal 0j. So what plus 0 equals 0? That should be 0. And then finally, if I do my third one, right? So let's see, k's. 1k plus how many k's should equal 4k's? So I think in this case we're going to have 3. All right, so now I have my constant vector. It's 2, 0, 3. So now let's go ahead and put that all together on this final line up here. So r of t is going to be equal to negative cosine of t plus 2, and that's all the stuff that's in the I component. So again, I was looking here, negative cosine, and then I know that d1 is 2. So that's all my I stuff. Plus, for my j stuff, I have t cubed plus t plus 0. That's all the stuff in my j component. So again, t cubed plus t plus 0. That's where I was looking. And then finally, for my k component, let's see, I have e to the 2t plus d3, which was 3. That's my k component. So again, e to the 2t, that has a k next to it, and d3 has a k next to it. So that's all the stuff that's in my k component. All right, so there are our final answers for v and r, right? Velocity and position. Again, that's a 13.4 problem that's shown up on a previous exam. I hope you guys enjoyed. I'll see you next time.